This week, we're going to be looking at volume, in particular with rectangular prisms, and drawing volume by using centimeter cubes. Now, this paper that we're using is called Isometric grid paper. So if you remember a while ago in class when we were drawing graphs, the grid paper was just like squares. This is a little bit different because the dots are offset. Okay, you can't really draw a bar graph with this thing. So what I'm going to do first is I'm going to draw 1 centimeter cube. So here is 1 centimeter cube, just like that. There. So this represents 1 centimeter cube. Okay, I want you to remember this little 3. And down the line, it's also good to know that 1 centimeter cube is 1 milliliter. So if you go to your fridge and get like a carton of milk, maybe you could tell me how many milliliters it is. So milliliters is a measure of capacity, like liquid in a container, right, to determine how big a container is. So let's look at the rectangular prism that we have here. Okay, so here's our rectangular prism. Now, some people can look at it and they can just count the cubes. Like you could count the cubes to get the volume. So there's 1, 2, 3, 4, 5, 6, 7, 8. Right? And then, people can keep counting here, and then they would find out that there's 16, but there's some cubes that are hidden, and it's hard to do. So some people just, they have to see the numbers, and actually everyone needs to know how to explain it, so numbers are always good. Now, what we're going to do is we're going to take a slice of this shape, right? So we're going to take really the front part, like it's the front slice, and we're going to draw it. So you'll see what I mean when I draw it if you're not exactly sure what I'm doing. There we go. So this, what I drew, is like a slice. So it's like this part here, right? And I can say that it has a length of 4, a width of 2, and a height of 2. So it's 4 times 2 times, I caught myself there. Silly mistake. Okay, it has a height of 1. And we can multiply it. So 4 times 2 is 8 times 1 is still 8 centimeters cubed. Okay, now I said to remember that little 3 here. The little 3 is like centimeter cubes because you're counting centimeter cubes. But it also tells you that there's 3 dimensions. There's a 4, 2, and a 1, right? So it's a measure of 3 dimensions. So you always have to remember the centimeter cube in your answer. Now, what I drew here is only part of the solution because this was the original rectangular prism. But as we go forward, we know that I basically did like all of the front face here, right? So the dimensions have changed, right? So I could say that it still has like a length of 4, a width of 2, but instead of 1, now the height is 2, right? So I can multiply them. Or I could say that, this is all 8, right? And it's 8 times 2. But, I can still, or here we go, it's 4 times 2 times 2. Now, 4 times 2 is 8, right? And then we could just drop the other 2 here. So 8 times 2 is 16 centimeter cube. Okay? So let's move on to the next shape. Okay. So here are some odd-looking shapes. Now, again, some people could just count the cubes, right? And count the cube. Now, to do these ones, what I would probably do is kind of split it up into portions. So if I look at this shape, I see a rectangular prism at the bottom, right? This one would be a mix of strategies where we'll use the numbers and the volume for the bottom, and then maybe we could just add on the top one, the top cubes here, because I know there's 6. Okay, so basically, right, this rectangular prism here is 6 centimeter cube. It's not hard to count because there's 1, 2, 3, 4, 5, 6 centimeter cubes. The bottom part has a length of 3, a width of 2, and a height of 2, right? So it's 3 times 2 times 2, okay? 3 times 2 is 6, and then, this times 2 is put on, right? So 6 times 2 is 12 centimeter cubed. Now that's the bottom, right? And I can take that 12 centimeter cubed and I can add the 6 from the top, right? So there's a 12 centimeter cube, and we're going to add the 6 from the top. And altogether we have 18 centimeter cubed, okay? The next one is probably, as difficult as an example as you're going to see. And the way I would probably look at it is that you have 3 rectangular prisms, right? You have, I should have a pointer going. You have the rectangular prism at the bottom, you have one in the middle, and you've got the one at the top. Now, the one at the top is, the simplest part. It's 1 centimeter cube. So whatever answer we get, we're just going to add 1 centimeter cube to it. So let's look at our numbers. So the bottom one has a length of 5 centimeters, right? So it's 5 centimeters from here to here, right? There's 5 cubes, so there's 5 centimeters. It has a width of 5 centimeters, and then it has a height of 1, right? 1 centimeter. And that's just the bottom part. So I can multiply my 3 numbers. So I would have 5 times 5 times 1. Okay, so 5 times 5 is 25. And the 1 is put on here. And it's 25 centimeters cubed. That's the bottom layer. Let's look at the middle layer. So the middle layer has a length of 3, a width of 3, and a height of 1. Right? So it would, our formula would be 3 times 3 times 1. Okay? Now, 3 times 3 is 9, times the 1, which you add on, right? So it would be 10 centimeters. Oh, beg your pardon. 9. So 9 times 1 is 9 centimeter cubed. So now we're going to add the bottom layer, the middle layer, and the top layer. Okay, so it's 25. Is 25 plus 9 plus 1. Okay, so I can keep going. I could say, well, here's 10. So if I just add them together. So the whole structure is 35 centimeter cubed. And again, somebody could count them, but again, it gets a little bit harder as the shapes or the figures get a little bit more difficult or hard to see the hidden cubes. Okay, so we'll move on. Here's a rectangular prism, and sometimes, like when you think about volume, it's really 3 numbers that multiply together, right? So 3 numbers that multiply together, and you could say that I could say that the length here is 4, the width is 3, and the height is 5. Right? Now, other people might say it's 5 times 3, and then the height is 4. It doesn't matter which one's the length, width, or height, as long as you get the same numbers. If you think about the first question, when we had slices, we can solve the question like that, and we could say the first slice, which is here, is 5 times 3, which is 15, right? And then there's 15 here, there's 15 here, there's 15 here, and then there's a final 15, right? So you could say it's like 15 times 4. Okay, but anyway, let's solve this one. So we would say it's 5 times 3 times 4. Or like I said before, and I could put the brackets just so that we know that 5 times 3 would come first. So 5 times 3 is 15, which is, like I said, the first slice, right, is 15 times 4. Okay, so 15 times 4. So here's 15. Here's another 15, which will give you 30. Here's another 15, which gives you 45. And then here's a final 15, which gives you, I'm pausing for you, so 15 plus another 15, it would give you 60 centimeters cubed. Okay, and final example. Okay, remember I said that volume is really 3 numbers that are added together. I'm sorry, 3 numbers that are multiplied together to give you a number. So this is a little bit more challenging, but I can give you a volume. I could say, okay, the volume is 27. How does the cube look, right? And I can say, okay, maybe the first one has a height of 1. It has a length of 27, and it has a width of 1. Because if I multiply these 3 numbers, I get 27 centimeters cubed, right? Or I can say, how about 3, right? So maybe it has a height of 3, and that means it would have a length of 3 and a width of 3, right? Because 3 times 3 is 9, and then 9 times 3 is 27, so that works. You can also draw these out. Now, I'm not going to draw 27 times 1, because then it'll be larger than a screen. I have to move it up and down. But I could draw this one, the 3 times 3 times 3. So here we go. Here we go. 3 times 3 times 3. So there's my length of 3. There's my width of 3 and my height of 3. Right? Just like a Rubik's Cube. So 3 times 3 is 27 centimeters cubed. Now, when all the numbers are the same, you might as well know that it's called a perfect cube. All the numbers are the same. It's a perfect cube because the length, the width, and the height are the same. So if we review what we did, and we're not going to review it all, because it was quite a bit. We started out with basically a rectangular prism here, and I wanted to show you that you can add it by slices, or you can solve it by slices, right? So here's a slice, and we took one of the slices, which was 8 cubes, and then we recognized that it has a height of 2, right? So that 8 times 2 is 16, okay? Then we went on, we did irregular kind of cube shapes. And basically, you could say we tore it apart, like we decomposed it. So we recognize that there are, there's 2 rectangular prisms here. There's one here, and there's one here. Okay, we broke it apart, and we figured out that there's 12 along the bottom, so 12 centimeter cubed, that there's 6 at the top, and then we added 12 times 6, which is 18. This is the same idea, except we had a rectangular prism along the bottom. It's like 3 steps, the middle and the top. We added, so there's 25, and then there was 9, and then there was the 1, and then we added 25 plus 9 plus 1, and we got 35 centimeter cubed. Okay, next. It's just a rectangular prism, and again, it pushed this idea of slices. So that you can have, here's like the front slice, which is 5 times 3, okay, which is 15, and then there's 4 slices, right? So then there's 60. Or you could just say, here's the length, there's the width, there's the height, multiply them all, 5 times 3 times 4, and it's still 60 centimeters cubed. Now, for the challenge, I gave a volume. So the volume was 27. And we talked about two different rectangular prisms, 27 times 1 times 1, length of 27, width of 1, height of 1. And then we did, well, how about a length of 3, a width of 3, and a height of 3, right? And then we took that and we were able to draw a rectangular prism that has a volume of 27 centimeter cube, right? And because it has the same length, width, and height, I also gave the extra information that this is an example of a perfect cube. Okay, so this lesson involves, I don't think it's difficult. It kind of goes on with progression of difficulty, but I also want to encourage you that there's nothing wrong with listening to the lesson twice, even if there's maybe just one little part you didn't understand. You rewind and you just listen to that part that you didn't understand. So if you didn't understand the last part, which I think is the most challenging, about getting the volume and then drawing the shape, you can just replay that part, okay? Because sometimes my recap just goes quickly. So pause the lesson, go back, do what you need to do, or if you have any more difficulty, email me, okay? So